Welcome, everybody. I'm Pierre de Vries with Dale Hatfield. I'm co-director of the Spectrum Policy Initiative here at Silicon Flatirons. It's wonderful to see you all here today in spite of the first snow of the year. Thank you very much for braving it. You won't be disappointed. We have a wonderful lineup. Before I say a few words about the conference, I just wanted to do something very special, something we've been waiting for a long time, to introduce Amy Stepanovich, our new executive director of Silicon Flatirons. She's an expert in domestic surveillance, cybersecurity, privacy law, comes to us from Access Now, Washington, D.C., advocacy organization, very experienced in the policy space, very experienced in technology. And I'd just like her to introduce herself to you. Please go and say hello to her later on. Amy.
Thank you so much, Pierre, and thanks for all of you for coming here today. When the staff told me on Tuesday that it was meant to snow today, I laughed because I just moved here from DC and I couldn't imagine 79 degrees outside, that it would snow 2 days later, and yet I woke up this morning and there it was. So I really appreciate you all coming out today. I want to thank a few people before we get started, in particular Dale and Pierre, as well as Keith and Scott for the work that they've done putting the program together today that you're all about to see. I want to thank our amazing staff for their tireless work. Kelly, Vanessa, Sarah, and Heather have worked really hard, and if you see them around, I hope that you have a chance to say hi. They really try to put their heart and soul in these events. I want to thank our speakers who are able to make it. I want to thank our supporters and our partners, without which we would not be here today, being able to provide this program to you. And finally, I want to thank all of you for coming and for bearing with us and with the weather. And I cannot wait for this program. I'm really excited for it, and I hope that you're all there with me. So have a great day, and I will talk to you all, I'm sure, throughout the day and throughout the breaks. And I'll turn it back to Pierre. Thank you.
Great. Thank you very much. So to talk about this conference, Saving Our Spectrum, handling radio layer vulnerabilities in wireless systems, why this conference? Why now? Radio services have always been important for more than 100 years, but they're rapidly becoming essential, something we cannot live without. And the question of what it means to secure these wireless systems, to make sure that they're confidential, that the integrity is maintained, that they're always available when we need them, is something that researchers and academics and industry has been working on for a long time. But we have the sense that it's something that policymakers have not been focusing on with as much attention as perhaps it merits, particularly at the radio layer. And so to address that, we've gathered together the community. This is a follow-on from a roundtable we had in Washington, D.C. in March, and there's a link to that if you go on the event webpage if you want to read more on that. We're going to focus on the radio layer of these wireless systems today. A couple of reasons for that. One is that obviously cybersecurity is an essential topic. It's an unavoidable topic, but there are lots of people working on it, and there are lots of conferences about that. What makes radio special, unlike computers that are plugged into the wall through wires, for example, is that in order for them to work, they have to be open to the world, because if your radio can't hear anything, it doesn't operate. So in addition to all the cybersecurity challenges that one has with the radio system, they don't have the refuge of hiding behind a wire or a fiber. And as Keith Gremben has said, how do you secure something that everybody has access to? And so that's the goal of this conversation, to help us begin to map out what some of the risks are and understand how we prioritize the scarce resources. I just want to ditto all the thanks that Amy expressed, but just a special thanks from Dale and me to Keith Gremben and Scott Fox. They're our unindicted co-organizers for helping us trying to put all this stuff together. A couple of announcements just for background. If we could just have the screen off, please. The first is this event is being live streamed. It is open to press. If you have a Twitter habit, the hashtag is hashtag Silicon Flatirons. In order to facilitate as much conversation as possible, We've asked the moderators not to actually provide detailed introductions to their speakers. The speakers deserve detailed introductions, but you can read faster than the moderators can talk. So please, if you want to know more about somebody, just look it up in the program. For those of you who get overwhelmed by lots of conversations, and I'm one of those people, behind that wall, we have something called the Introvert's Refuge. So if you need to take a break, go out the back door, make 2 lefts. The rule there is no communications, no phone calls, no conversations, and if you can help it, no eye contact. It'll help introverts like me to just decompress. All right, so let's get going with the program. So, as we all know, there are millions of public servants in this country. And if you go to Washington, D.C., there are tens of thousands of people who work for the federal government. I know a few of them, and the people I know are dedicated, hardworking people. But if I had to hold up somebody who I know from personal experience truly serves the public, it would be Julie Knapp. Mr. Knapp is the chief of the Office of Engineering and Technology at the FCC. I probably shouldn't say this, but I believe he's been at the FCC longer than I've been out of college. He rose through the ranks. He became chief of the OET in 2006. He served 4 confirmed FCC chairs of both parties. And every day that Julie remains in government, and you know, the siren song of working in the private sector for a lot more money, he's successfully resisted. And every day that he's in DC working at the FCC is a good day for all of us. Julie's patience and good humor are amazing. That's probably why he's been in the job for so long. But everybody who's worked with him knows Julie's self-deprecating laugh. It not only diffuses tension, but I've learned that when you hear Julie give that little laugh, that's when you really need to pay attention. But you don't only have to pay attention then, you always need to pay attention to Julie Knapp. And so with no further ado, Mr. Knapp.
Can I stay behind the curtain?
No. The Wizard of OET, ladies and gentlemen.
Oh, thanks, Pierre. Let's see, have we got this keyed up? Go. Should be able to do this. There we go. We're not getting on the screen. Let's try this. This doesn't look like it's connected.
It looks a little frozen, doesn't it? We get IT.
So how'd you like that technical presentation?
Great.
Where are all the students? See, the students stand at the back because they're afraid they're going to get pulled up. When you get older, you move to the front because you can't see the screen. So I want to ask for a show of hands of how many of you read the prep material? The people who did the prep. So how many, after you saw about all the vulnerabilities to the pacemakers and the presidential EAS announcements, have decided to disconnect everything? We're good? Just about done. was hearing stories about it was like 4 hours, 3, 4 hours. No, no. Yep, yep. That's my routine commute. DC. This doesn't work. We'll do it without this line.
Yeah.
Let's get going. I had some really fabulous slides. So, one of the things I wanted to point out is how just about everything in the world today is going wireless. I don't know if you can hear me in the back, but I'll try to speak up louder. Just about everything today, you're looking to replace the wires with wireless. And I still recall an FCC spectrum policy back in the 1950s, recognizing that spectrum is a precious resource. And we now have wearables, devices that are carried on the body itself. And don't ask me how they get embedded. What happens to them after they're thrown in the wash? Smart cities. Utilities. All right.
Mic is turned on.
Yeah, good. So, when we don't have our cell phones with us, we feel like we're missing an essential piece of equipment. I've mentioned this a few times before, but even wireless in socks, and I was wondering, what the heck do you want wireless in socks for? Although today would probably be a good day to try them out because they're heated socks that you can actually control by Bluetooth. So just about everything is going wireless. When you stop and think about our vehicles and count up all the ways that they are connected, GPS, and then there's the entertainment, satellite radio, AM and FM, your toll tag readers that we've had for a long time. Ultrasound, actually, you're using radio signals to vibrate the sensors. The connection of vehicle to vehicle and vehicle to infrastructure. The electronic controls, which maybe don't transmit, but also use radio frequencies. Tire pressure monitors that have been around for a while. Of course, commercial wireless and Bluetooth and Wi-Fi, and I've said this before, they don't advertise how big the engine is anymore or the styling, just as whether it's got Wi-Fi and Bluetooth or LTE connected to it. So I just thought this was a good example that we don't appreciate how much wireless is embedded in the things that we just do day to day. And then 5G. So 5G is going to greatly expand the use cases. And even with the list I have up here, it's not everything. Public safety, transportation, healthcare, education, energy, media, smart cities, agriculture, building and home automation, and others. And certainly you're going to hear about a little bit later today about DoD's interest in the applications there. So more coming for connectivity. So what are the, some of the technologies? This is a slide that really originated from our Technological Advisory Council. When you think about all the different ways things can be connected, let's not forget about wired for a minute, because wired plays a role too. Certainly cable systems is a great example. So all these systems can tend to be hybrids, part wireless, part wired. We have the wireless personal area networks and sets of standards there. The local area networks, our home wireless routers, the wide area networks, all of the Gs and so forth. So there are lots of ways and lots of standards for ways you can connect things. Now, spectrum. I thought I'd throw in spectrum since it's in the title for the conference. So on what we think of as the licensed side, because we've been providing for flexibility in all of the commercial wireless bands for a long time. So we're all familiar with the cell phones, but when you go to conferences, maybe you'll see what has been offered for years as M2M, machine to machine, before the term IoT really came into vogue. So those things have been around for a while. We've made spectrum available, a whole bunch of bands. I won't go through all of the details of them. But more recently, 600 megahertz band through a TV incentive auction. We just working with NTIA and the Department of Defense have turned on the initial commercial deployments of what I think is probably the most sophisticated dynamic spectrum sharing system in the world for the Citizens Broadband Radio Service at 3.5 gigahertz. We've opened up new license spectrum at 24, 28, 37, 39, and 47 gigahertz. And I always feel like saying hike at the end of that. And in one of those places at 37, we're working with DoD to find ways that we can implement even more advanced sharing. We've got two proceedings that are pending that are getting a lot of attention. One is what people refer to as C-band, because a lot of the world is looking at what's called mid-band spectrum for 5G in roughly the 3.4 to 3.8 gigahertz range, give or minus a few gigahertz. And then at 6 gigahertz, because unlicensed is also needing room to grow, is interested in sharing spectrum at 6 gigahertz with point-to-point microwave and a few other services. And then on the unlicensed side, sometimes folks have the misunderstanding that there's just unlicensed bands. Well, these are bands that are actually were provided for industrial, scientific, and medical equipment that generated large amounts of noise. And so you've got unlicensed working at 915, 2.4. There's a whole bunch of frequencies at 5 gigahertz. We've opened up more spectrum at 57 to 64 gigahertz. We've opened up spectrum roughly in the upper 70s, 76 to 81 gigahertz for vehicular radars and so forth. And we've actually opened up spectrum above 95 gigahertz for unlicensed use. So, the downside is if you're looking about spectrum vulnerabilities, there are lots of bands to be thinking about. So, how many of you have read the report from the roundtable? All right, so I'm just going to give you a high level overview because I was very impressed. So Silicon Flatirons, and partly what sparked why we're here today, had a roundtable to talk about this very topic. And I've only clipped a part of the conclusion out of this because there were a lot of ideas. I'm going to talk about them in a minute. So, and I'm going to read this to you. So the conclusion was the roundtable discussion was only the starting point. More challenges were raised than solutions proposed. I think the solutions all come in the third panel today. Is that what? Yeah. The participants agreed that further discussions must take place to assess challenges and develop more detailed solutions on how to address them. There was consensus that a conference or another roundtable that brings together experts in government, industry, and academia is appropriate as a next step. I'm not going to cover all of the different kinds of vulnerabilities that were discussed in there, but I'll just highlight a few of them and maybe share an idea too. So the workshop objectives for today, and again I just clicked, was to explore the risks of increasing reliance on wireless systems and access to spectrum and discuss ways to solve such problems. And also to focus on the radio link, then conventional cybersecurity issues, the challenges created by radio receivers necessarily being open to incoming signals in order to function. And as I was preparing for this, struggled myself to separate cyber because it's kind of a piece of it, but it's a whole subject unto itself. I think the intention here was to focus more on what happens with the radio portion, the new pathway into the devices that opens vulnerabilities. And there were examples in the prep materials of spoofing presidential alerts, protecting GPS from spoofers, new security flaw impacts in 5G, 4G, and 3G. At least 2G escaped. So most dangerous hacked medical devices and can Internet of the Body thwart cyber attacks on implanted medical devices. And when you read these things, it certainly gets your attention. But I will tell you also that, what these really signal are lessons learned and things to think about going forward. So one topic was interference. What do you do when your thing stops working? And you're not an engineer, you don't really know all about the spectrum and things. So one of the challenges is we've got a lot more things out there that are relying on the airwaves. And it's sometimes not appreciated because folks point to somebody else's product as generating noise, when indeed every product generates some spurious noise and contributes to the soup. But it's a challenge with things that we have more of them. Some of them are operating with extremely low signal levels below the noise floor. So we continue to have that challenge. One of the issues is, how do you know if your product is not working as well? What's the cause? Is it interference? Is it there's a little more noise? Is it the loading on the network that you're not seeing as good a performance as you had seen at other times? So we still have that challenge. Spectrum management, I think, falls largely on the FCC and the NTIA, and on the NTIA side, working with all the federal agencies, and it is not easy because we're always trying to put new things on the airways and allow for innovation for the new applications that you see coming out all the time, which is a good thing. But for the incumbents, that what they care about is it's not going to disrupt the services that they are doing and are important as well. So one of the things it talked about is the challenges of how do you collect data on this stuff? How do you really understand what's going on? And that's pretty hard. And I think one of the things out of the report was things are somewhat lacking there for people to, but the questions become, well, what do you collect? So if you got a phone and it's getting, and its throughput is reduced because the noise level, how would you know? And who collects it? Because there's immediately privacy concerns when you start collecting this kind of data from folks. And then reliability of the data. You'll often see people, one of the things I do with our engineers is the data you're looking at, was it all collected the same way? Was it calibrated? Do you really understand what it means? And then how do you interpret and analyze it? So I don't know that there's easy answers there, but certainly that was one of the things that was flagged in the roundtable. And then identifying and mitigating causes of spectrum vulnerabilities. And I think a great starting point is the system design and complexity. You have to build the protections against vulnerabilities into the design. And you quietly see some of this with things that are out there and have been emerging over the years. For example, for some of the IoT things that go blip occasionally, well, if there's a handshake, if the signal didn't get through, it goes blip again. Now you got to balance that against, what's your strategy? You don't want to do it maybe necessarily one right after the other. You don't want to keep doing it till the battery runs down. But it's one of the things that people do, recognizing that because they're using the airwaves, at times they may be vulnerable to interference and the signals might get through. There was some discussion in there about the advantages of what I'm loosely calling the dynamic capabilities. So most of these products that you've got, or at least on the commercial wireless side, they operate across multiple bands. There's probably more than a dozen different radio transmitters in your cell phone, whether you realize it or not. And they're capable of operating in different modes that are stronger or lesser strong, making trade-offs for the signals getting through. And the network is going to manage it that if you're not getting through one place, it may move it to another band. So the robustness, as well as I think, some of the features you're seeing implemented through software-defined radios, which have taken a long time coming, but are better able to deal with some of these problems. And then standard setting. I think you're seeing more and more now where the standards bodies are making a strong effort to build cyber into the standards. But how can you be sure that they got implemented the way they were intended? And maybe it's built into an industry certification process, but one of the things, and I'll talk about this at the end, is trying to anticipate every way some 12-year-old who's up to no good has figured out a way to undo all your protections. The availability of harmful equipment. So we have an equipment certification program at the FCC lab. I can tell you that we would not certify a piece of product that came in and said, I don't know why anybody would be so unintelligent to tell us, here's what I've got to spoof the president's emergency alerts. So, the first line of defense is the products, and just seeing if there's, we have a public interest standard, and if we see something that is clearly out there to be put out for no good, it wouldn't get authorized. And then there's enforcement actions that we can take. So one of the things that makes it easier, having been a supporter of the enforcement for quite a while, is that used to be, if you wanted to find out what was on the market that was illegal, you'd have to look through magazines and, rely on complaints and stuff. It's pretty easy to find out now. It's right there on the internet, people selling it. But that's also the downside, people selling it on the internet. And so they've got more avenues for distribution and volume, and it is a constant challenge. I will also tell you just the process of enforcement. These aren't like parking tickets, these are legal actions. So basically our enforcement bureau has to prepare, first to do the investigation, then prepare what's called a notice of apparent liability or a notice of inquiry to build a case. Jammers, because there certainly has been concern about things like GPS jammers and so forth. We really try to focus on them because it's safety related and go after them. But it is tough because of all the different ways people can find to get them out there. But this on our website, they're prohibited. So there's no question about those. So some lessons learned from some past experiences. You can probably tell I've been at this for a while. And these are only a few of them. So the garage door openers, and there's a lot of misinformation about what happened. But, in the early days, not everybody had a garage door opener. They didn't have to worry too much about you hit the button and your door went up. If you started to see everybody else's door on the block go up, you started thinking maybe something's wrong here. So early on, what the industry did is put in something called dip switches. Basically, you would set the switches to a unique code for your garage door. So it started to see some security, so to speak, because a lot of people use their garage door openers to get into the house. But they were still, certainly by today's standards, very basic. So the protections have evolved over time. And in this industry, I don't think I've heard a report about a door opener going up because of this sort of thing. They're using some pretty sophisticated codes now, but it's from the lessons of those early days. Cordless phones. And I was directly involved with something, brand new products coming onto the market, late 70s, early 80s, and you'd pick up your phone, and not only could you listen to the neighbor, but maybe when you were dialing the phone, they were dialing their phone, they were dialing yours too. And so they really didn't have any security codes whatsoever in them. And there actually was a debate at the commission about whether having 64 different codes was enough. And you could look at this and say, this is going to happen. So sure enough, after 2 years, when we first started looking at the issue, and people were careful, they didn't want to overregulate, the phones were dialing 911 because with the poor security, they would react to noise, and so the police they were obliged to go out, and so it had to be fixed with more sophisticated algorithms. Wi-Fi. So Wi-Fi was terrific, came along, and probably in the early 2000s you started to hear about, well, wait a minute, somebody's outside my house tapping into my Wi-Fi system. And the industry has progressively built more and more security into these things. But, don't get your device and not activate the security and leave the password as password and the username as admin. So when we started talking about, well, what can a user do? There are things you can do yourself. But they started after this, and not always, but most people are using the security features on their routers now. And then the first generation cell phones. So this was a fun story for me. So it's a little bit telling if you can translate it into some of the challenges that we have today. The first generation cell phones were analog. They actually used was 30 kilohertz FM channels. And so, you got assigned the channel you were on, but you could overhear people. So Congress passed a law that said radio scanners must not be able to tune the cellular bands. So through our equipment authorization program, every time somebody filed for what people thought of as a police scanner or a scanning radio, because a lot of people like to just listen to what was going on, the manufacturer would declare this device is not capable of picking up in the original 800 megahertz cellular bands. And this went on this way for maybe 2-3 years. All is good. All of a sudden, a high-profile political figure had a sensitive conversation eavesdropped and made public to the nation. The general counsel of the FCC, with me in the second seat, was testifying before Congress. And Tom Wheeler, who later became FCC chairman, and Tom was the head of the Cellular and Telecommunications and Information Administration, CTIA at the time. And I still remember the demo that he did to start the conference. Billy Tozen, Congressman Billy Tozen, was the chair of the committee. And he came down and Tom said, look at this, snip here, snip there, put a jumper there, and suddenly you could pick up the cellular bands. And so what did we end up doing? We were brilliant. We said, okay, you got to put glue all over the chips, so you can't get at the pins. Of course, the later generations were digital, and it's not that they're completely immune, because there's always somebody out there. So last slide, just some closing thoughts, in the discussions today. Everybody has a piece of this. Everybody plays a role. Government, and I use the term government because there's so many different agencies and departments that are involved in trying to deal with the cyber issues and the kinds of things we're talking about today. It struck me when we were talking about the pacemakers that they were hacked. The security is examined by FDA when they authorize them. So even building in those protections, with the government oversight, it didn't close every loophole that was out there. The network operators, the standards organizations, and trying to do everything they can to build security into the standards. The equipment designers, that they don't like the garage door opener folks. Think about this afterwards, because then it becomes a big problem and a very expensive problem to fix. And the application developers, because sometimes the application, that's the pathway into the hardware. We're going to always strive to eliminate the vulnerabilities, but recognize that some vulnerabilities are probably inevitable. When you get in trouble is when you think that I'm good, I'm following the security standard, what could possibly happen? And it's a good thing, actually, I think, when you have groups or universities that are out there and, announce publicly or to the standards organization that we found this hole, because then you can fix it before it becomes a problem, before it's out there and you've got a major problem on your hand. And then prioritizing the attention to vulnerabilities is appropriate, particularly for safety applications. You try to tackle everything. It's probably less of a problem if my wireless thermostat didn't get through for first try, as opposed to GPS on a plane or things like that. So anyway, a few things to think about. I ran a little bit long, sorry about that. And should be a great day. Thank you.
Thank you very much, Julie. Julie is always willing to entertain questions. Since we're running a little bit late, what I would suggest is if you have any questions, please buttonhole Julie during one of the breaks, or not. The guy who's running down the hallway very fast is Julie. Thank you very much. So we're going to move on to the panel, the first panel. What I will do, I'll introduce the panel at this point. I'll ask the panelists to just come down, make themselves comfortable. If you want, we're going to play 2 videos to start off with. So if the panelists want to just sit in the front row, they can do that too. The first panel that we're going to have is talking about the mobile communications industry. And to give you a little bit of background, the topic of the conference, as you heard from Julie, is huge. And we could have talked about any of a number of different industries. What we did was to pick 2 that to some extent bookend the problem. One is the mobile communications industry. This is a very mature industry. There are a few big players. It's something we all know about. It's actually very deep and important infrastructure. It's very mature. On the other hand, so that's this panel. The next panel will be Internet of Things, particularly in the healthcare area. That's relatively new and emerging. It's a very, very diverse industry. There are many players. There are lots of new and emerging problems there, and it's very different from cellular. So we're going to talk about mobile communications first. What I want to flag to you is we've had a lot of people drop out of the conference very recently as a result of health issues. One of the things I would suggest is that work in the healthcare industry, because we had 2 people drop off this panel. We had 2 people drop off the closing panel, but nobody dropped off the healthcare industry panel. So they're a very healthy crowd. So we had two people that were going to speak for us on this first panel. Tom Sonabori, who is the Senior VP and CTO of CTAA, which is the Cellular Industry Trade Association. He was unable to travel due to a health issue in his family. He has actually very kindly sent us a short video. This goes against what we do at Flatirons because we like to have a conversation with people, but because we felt it was very important for everybody to hear that perspective.
Tom Sonabori, CTO of CTIA. I have over 25 years of experience with technology, network, and operations of wireless networks. The wireless industry has baked security into our networks from the beginning, has worked diligently to prove security as we go from each generation to the next. Today's 4G LTE networks offer advanced security features, and 5G will be the most secure technology we have to date. 4G and 5G technologies have more sophisticated security than other technologies such as Wi-Fi and Bluetooth. While Wi-Fi is improving, it also depends on who manages the network, how well it's engineered and secured. Thanks to wireless, we're more connected than ever. There's more than 400 million wireless connections joining people, devices, and the internet, and that's only going to grow. Tomorrow's 5G networks will offer very fast speeds, improve latency, and support massive IoT. This will enable entirely new services and applications from industrial IoT, transportation, healthcare, and public safety. Meanwhile, however, cyber threats continue to grow both in number and sophistication from sophisticated hackers. While radio systems may be jammed or spoofed, it's relatively unlikely to occur and more likely to occur in isolated areas. There are multiple spectrum bands being used also, which mitigates the risk of a spectrum vulnerability. So our entire wireless industry must continue to work and innovate to advance security as we move to 5G and beyond. Our industry works collaboratively to understand improvements, leverage standards bodies and drive standards improvements, and employ best practices. Every part of the ecosystem has a part to play, starting with the device. The device uses things like SIM cards, which provide one end of mutual authentication with the network. We also use temporary identifiers, roots of trust, coding, and encryption. In the operating system and app store, we also want to make sure we have antivirus and anti-malware. We also want to validate applications to ensure they're secure before they're downloaded to consumers' devices. On the network side, we use the other end of mutual authentication in the core network with sophisticated authentication keys. We use IPsec and, of course, robust access controls to make sure only the people who are accessing the network who are authorized to do so. And as these networks become more virtualized, security must be more distributed. That will make for a more adaptable security environment. And of course, tools. Secure firewalls, VPNs, intrusion detection systems, these are of course table stakes. But as we move forward, things like automated artificial intelligence and machine learning are important tools to be able to find more sophisticated hacks. As we move towards 5G, networks are being deployed and actual security capabilities will be enhanced. First of those is enhanced privacy protection. With encryption of the device's unique identifier, known as the MZ, will further secure communications and minimize the risk of eavesdropping. Secondly, the ability to leverage 5G home wireless security when you're roaming or when you're on a Wi-Fi network. This better protects the devices, consumer data, and even the network. And number three, we have device security specific updates. This allows consumers to receive the specific technology updates meant for their device, whether you're on a smartphone, a tablet, or an IoT device, and provide native support for plug-in security. Of course, cybersecurity is a team sport. CTI and its members collaborate across government, academia, and amongst each other. Chief among those is with the Department of Homeland Security's National Risk Management Center, where the COM ISAC is headquartered in Arlington, Virginia. Here we share information about the risks and vulnerabilities in the 7x24 operational environment. CTIA also collaborates with NIST, NTIA, and organizations like the FCC. We're currently talking to NIST about a 5G security project. In addition, with the FCC, we convened the CISRIC groups to work on evolving security recommendations. Recently, we worked on things like SS7, the diameter protocol, and border gateway protocols to keep increase the security of networks. And we're currently working on, the new groups are focused on both the transition to 4G to 5G, as well as 5G security. So in summary, for the U.S. to continue to serve consumers and businesses and to provide innovations for vertical markets, our networks must be secure. And that's what our industry does tirelessly every day. Thank you.
Thank you very much to Tom Sawanabori for that. The second short clip that I'd like to play you is from Jeff Reed. Jeff actually woke up with a medical condition and his doctor said he wasn't allowed to fly. So he sat down and actually recorded a presentation for us. The link to the presentation should be up on the event website. I strongly commend that to you. Jeff is one of the leaders in the US and internationally in wireless research. He's a professor in the Department of Electrical and Computer Engineering at Virginia Tech. He's a founder of Wireless at Virginia Tech. He actually was one of the key players in the roundtable that Julie referred to. So to get his perspective, could we have Jeff Reed, please?
In summary?
No, we don't want to start with a summary. We want to start with that.
Hi, my name is Jeff Reed. I'm a professor at Virginia Tech. Unfortunately, I wasn't able to make today's conference due to illness, but I put together a few slides that I hope you will find to be informative. Hi, my name's Jeff Reed.
And there we go, second slide.
So here are some of the key points that I'd like to make. First, attacks on 4G and 5G can occur at any layer, including the physical layer. These systems are extremely complex. They're complex to analyze, and hence it becomes pretty easy to overlook vulnerabilities that may be built into the system. And jamming is always a possibility, but you don't want to make it so easy that protocol-aware jamming can take the system out with very little power. There's certainly a number of reported hacks on 4 and 5G systems. A lot of them were reported at the Black Hat conference. That said, as we'll see, 3GPP, the standardization group for 5G, has really brought security to a new level of consciousness. They've done a lot of work in trying to root out potential vulnerabilities before these systems are ever deployed. And in the way that 5G is put together through using such things as network slicing, you can develop your own authentication and customization of security. Nevertheless, we have to look at new ways to address security. These systems are so complex that we need to find, for instance, automated approaches to root out vulnerabilities. But there are some difficulties in doing research in this field, as I will explain. If you take a look at some of these pictures, I extracted these off the web. Here's an LTE jammer that you can buy on the internet. And here's an example of an IMSI catcher. This is the ID catcher for a GSM phone. This is put together by a group at the National Research Nuclear University in the Russian Federation, and it consists of 2 RTL SDR dongles. These things cost about $16 each, and they put them together to create an IMSI catcher. So you can see that this is not something that nation states can do, but it is something that college students could do. In summary, there's a lot of great new security features in 5G, and more coming in release 16. We'll see further refinements in subsequent releases. There are still some known vulnerabilities in 5G, including some of those that have been identified for 4G. AI can have an important role in finding and mitigating these vulnerabilities. And finally, research in this area is important, but it's expensive and difficult to do. It is something that needs to be addressed by the research community.
Very good. So let's get into the conversation. Something fell off.
It's on the ground.
I'm dragging. I think you'd probably prefer not to hear me, but we'll see. All right. Do the sound check. Can everybody hear me? Can you hear me in the back? Yes, thank you, Dan. So actually, the first thing I'm going to do is I'm going to break the rule of no introduction, since we have somebody who has stepped in. Scott Fox has actually stepped up to join us on the panel. Scott is a veteran of the wireless industry. He's been in the industry for 40 years. He's been in a whole range of positions as an executive. He was CTO and a senior leader at Bell South. He's actually been very active in trade associations. He was chairman of the Global GSM Association. And also he's worked in public-private partnerships. He was a lead advisor for FirstNet. You've heard, actually, both of the first two speakers, you heard talk a lot about 5G, which is the evolution of the cellular network, which I imagine all of you have heard about. Something that not everybody may have heard about is FirstNet, which Scott has been very active in. Scott, do you want to say a little bit about FirstNet and what you think we should know about that?
Sure. Thank you very much. It's nice to be here. It's nice to be at a conference in the town you live. It's really special, right? But at a high level, and I'll keep it very simple, FirstNet is a federal agency who's been tasked by Congress to develop, deploy, and operate the next generation wireless network for our nation's first responders. Congress came up with this conclusion years ago and wanted the first responders who have a number of kind of challenges with their existing systems to be able to take advantage of global economies of scale for devices, to be able to keep on the leading edge of technological development. Whereas previously they had used what's called kind of dedicated spectrum, largely proprietary solutions around what we refer to as LMR, or land mobile radio. And again, FirstNet was largely created as a result of 9/11 and the realization that interagencies, and I think there's something close to 50,000 public safety entities in the U.S. And by public safety, I mean police, fire, emergency medical, largely, and it can go beyond that. But FirstNet is the federal agency was tasked with coming up with a plan. They were given $7 billion to do it, not nearly enough. The conclusions were that they didn't have the time or money to build a dedicated nationwide network quickly enough. So they took the next best approach, right, which was to create a partnership with an existing wireless operator. In this case, AT&T was the one who bid and won that relationship. So you'll see FirstNet, built. So there's really two entities, right? AT&T, who we'll talk about. FirstNet is delivering the services across the network, and FirstNet, the government agency, who is really directing and overseeing their activities.
So what we have here is a public safety network, which is being delivered largely over the same network that we use as consumers. Yes. So there are clearly upsides in this. Are there any downsides?
Well, sure, right? I mean, ideally, it'd be great to have put a lot more money into it, built a network which is, quote, hardened, which means, the towers are really hard to take down, right? The fiber connections are highly protected. So to upgrade an existing network is quite challenging. But again, it's a reasonable compromise, right? It was a compromise to get out there quickly, to take advantage of existing assets that were out there, not just physical assets at the network layer, but also the resources to build, design, evolve the network. It's going to take time to continue to harden the network, right? In this case, AT&T is investing lots and lots of money into it, funded by FirstNet largely. So there are a lot of trade-offs, right? But at least the public safety has the advantage of, you know, having voice, data, and other super fast connectivities right away.
One of the things that comes to mind is that in the past, public safety as an infrastructure, and still large parts of it, Jay knows that very well, he can tell us more, was completely independent of the LTE cellular network.
Yes.
And when you're trying to secure a system, make sure that it's always available, you really don't like single points of failure. So have we built ourselves a single point of failure?
We have. Virtually. It's a virtual single point of failure, right? So, you know, on one hand, public safety is now in the process, and we hope faster than slower, is moving on to FirstNet as FirstNet's capabilities continues to grow. And so this is very public. Everybody knows this is where first responders are going to be. So previously these land mobile radio networks were dispersed. They were hard to find, perhaps. But if there was an outage, it would be localized as well. So this consolidation to a single network does raise the risk profile. But there's also ways to mitigate that and offset that as well.
Right. So we'll come back to some of those kinds of issues. I'd like to change gears. You will have heard both Julie and Jeff talked about IMSI catchers, also known in the trade as stingrays. And we have one of the international experts on this here. Yomna is going to hopefully tell us what IMSI catchers are and why we should care.
Yep, so I have a bit of a cold. Can you hear me in the back? Because I can't project too much. So IMSI catchers, also known by the brand name Stingray, are devices that sort of mimic cell towers. And phones connect to them because phones are not great at that part of security. And so they have three main capabilities. So you may have heard of like IMSI catchers or stingrays in the news, and so a lot of people are confused about like sort of what their capabilities are. But in general, there's three. This isn't like perfectly accurate anymore, given some attack details that were published within the last year. But generally, they're capable of doing location tracking, so either figuring out if a specific phone is either in a geographic area or absent from that geographic area, or like figuring out the exact GPS coordinates of a phone. And in fact, the worst location tracking attacks are only possible in like later versions of LTE. Then there's communication interception attacks, and this is what you hear people like worry about the most often. They think like, oh, someone will set up an IMSI catcher and like intercept my communications. But as far as we know, those kinds of attacks have not been possible since GSM, which is used very infrequently these days. Most of us are using LTE or 3G. And then the final sort of class of attacks is like signal jamming and like protocol downgrade attacks. So that's sort of what IMSI catchers are in a nutshell.
Could you say a little bit about what protocol downgrade attacks are? Because they show up in a number of different places, and I think most people won't have heard that term before.
Yeah, so say you're using LTE and you connect to an IMSI catcher that's pretending to be a cell tower. Well, when during the connection setup phase, the IMSI catcher will be like, oh, I only support communicating over GSM, and your phone will be like, okay, I guess I have to use GSM. So it's simply like the protocol that ends up being used is like GSM. That's what downgrading means.
So does that mean that if there is a 5G system and I've got a 5G phone and 5G has hardened itself against the kinds of things that IMSI catchers can do, if the IMSI catcher can do a protocol downgrade, I'm vulnerable again?
Yes. I think a big part of like deploying these like big complex systems is you want backwards compatibility, because you'll have people coming to areas where there are 5G networks, well, they'll have older phones, and you still want them to be able to connect. Yeah. So as part of that, that's sort of where protocol downgrade attacks come into play. Yeah, another thing I want to say sort of tangentially is a lot of the IMSI catcher style attacks that we know of, the root cause is sort of what we refer to as pre-authentication messages. So phones cannot authenticate that, like, towers they are communicating with. Like during the very early parts of like connection bootstrapping, like during the setup phase, when they're picking what tower to connect to. So that lack of authentication means, that lack of authentication has not been fixed in 5G. So a lot of the attacks we saw that MC catchers were able to pull off in like LTE and 3G are ultimately still, like they're still there in 5G. They haven't been fixed.
So one of the things that I really commend to you is that Yomna wrote a paper on IMSI catchers for the rest of us to understand what they are. It gives a lot of detail in a way that I found very understandable, and I strongly commend it to you. One of the things that I picked up from that is we, the public, don't actually know what IMSI catchers do. We only have what the researchers have been able to figure out because it's commercially confidential. And there is a trade-off that I want to put to you, which is IMSI catchers have an important social use. They're used by law enforcement. They're used by national security agencies. Is a community of researchers exposing how you can block them, the kinds of risks that you run through the existence of IMSI catchers? Are we giving the bad guys an advantage that they shouldn't have?
So I think in general, there is no way to block MC catchers. I recently decided that it was too depressing to like go around and keep giving like academic talks on MC catchers and cell network attacks, because afterwards in the Q&A session, everyone always asks repeatedly, so what can I do to protect myself? I'm always like, nothing. There is nothing you can do. I mean, like, of course, like, I believe law enforcement and like people who are like trying to hunt down criminals, whatever, should have ways to be able to like catch those criminals or whatever.
Right.
But should the way that they be able to do that be because our cell network security infrastructure is like so broken, absolutely anyone can take advantage of it? Like, that doesn't seem like the best like solution to me. I had something else to say, but I've forgotten.
Well, we'll get into a conversation soon, and actually both you and Scott have teed up some interesting questions about standards and the role that standards bodies can play in addressing these issues. We'll come back to that, but I want to turn to Jay. You know, we had Scott talk about LTE as part of FirstNet. Jay, for those of you who don't know, is sort of the dean of interference hunters in the US. Does a lot of work looking for interference, trying to understand what interference is. Some of the things that we've been hearing about so far are malicious attacks or sniffing. How would you compare the risks of malicious attacks and just interference?
Sure, I can answer that question. First of all, my wife calls me the king of radio, not the dean of interference hunting.
Okay.
I prefer king of radio.
King.
And my pronoun is Your Majesty. So
yes.
So we used to have an expression in the Air Force when I was an Air Force officer that of all the RF problems that we have that prevent us from using our radios, 90% of them we were doing to ourselves. And that category is called interference. If it's jamming, it's intentional. If it's interference, it's unintentional. That's the definition that the military uses. And it was basically true. There's a lot of interference out there. The public doesn't see it. The public doesn't even understand what's going on behind the scenes. But our company spends a lot of time working with AT&T, tracking down interference so those cell sites will stay up and work. So when you had coverage one day and you didn't have the next day, it could be due to a lot of things, but it could also be due to interference at that cell site that serves your neighborhood.
One of the things that Julie raised was, you know, your service stops working. Why is that? Are you able to help your clients understand what the root cause is, or is that often black magic?
Mostly black magic. It's actually not black magic. It's some tools, test equipment, computers to try to track down interference, but mostly it's experience. I'll give you an example. 700 megahertz cell phone use is relatively new, maybe the last 10 or 15 years. Before that, we did 800 megahertz. Now we do 800 and 700 and a bunch of other bands. But there turns out that there's a cordless phone that all the hotels use. They all use the same brand of cordless phone in their hotel rooms, and that cordless phone puts out what we call a spur. A spur is interference that's only on one frequency. It has no bandwidth to it, and it took us a while, but we figured out that spur was almost always present. And if you put a cell site too close to a hotel that has those cordless phones, that spur is likely to be there. It's not there from every cordless phone of that make and model, but it's there for a lot of them. You know, one case, I sent one of my technicians out to track it down, and he very quickly located where it was. He even knew which hotel room it was. And that was a combination of looking from outside and actually going down, up and down the halls and finding it. And he went to the manager and he said, we need to reset that phone, because the solution is actually turned off and on, believe it or not, just like computers. And the manager said, there's a guest there, we can't ask the guest to leave. It's just a rule, you can't ask the guest to leave. And so he waited 2 more days, and then when the room was empty, we reset it. So that's just one example, but the bigger problem is not the cordless phones. The big problem is the LED lights. Has anybody heard of LED lights causing radio interference? Okay, some people have. I'll give you an example. Every night when I come home and it's dark out, and I try to get in my garage with my garage door opener, it does not work. I have to actually get out of the car and hold it right up to the garage door to get it to work. It took me a while to figure it out, but my neighbor, who's right across the alley, has got LED lights on outside of his garage, and he has them on all the time. So that's one example, but a bigger example is Las Vegas. Las Vegas is all about LED lights. And every LED light bulb is not really a light bulb, it's an LED with a power supply. And the power supply is what causes the interference, specifically switching regulator power supplies. And when you put thousands of those up over the strip in Las Vegas, you're asking for trouble for cell phone coverage. And AT&T and Verizon have both asked us to track down those problems in Las Vegas. It's really difficult to fix, though.
You know, I want to pick up on something, and by the way, this is just an open invitation to the panelists. You should feel free to ask each other questions, too. You know, you mentioned that when there is a problem, it takes somebody to go out and figure out what it is.
Right.
We heard Jeff Reed, actually, and again, you only saw 3 out of more than a dozen slides. There's a lot of great stuff in Jeff's deck, which I commend to you. He talked about artificial intelligence in the deck. He said more about using AI and machine learning. Do you have a view on whether machine learning is going to help us? And actually, sort of a follow-on question for you, Yomna, is, you know, there are apps that are supposedly going to help you know if there are IMSI catches. Are they any good? So, Joe, first to you.
We hope so. So we've done some work for one of our clients to test AI algorithms to identify, believe it or not, whether a truck driver is using his cell phone. But that same approach could be used to identify whether there's interference. And you can imagine why trucking companies don't want their truck drivers using their phones and texting. It's dangerous, right? You're distracted. And so they take this very seriously, and they took it seriously enough to pay us to analyze whether that could be done. It's a difficult problem, though. It's a very difficult problem. Right. So right now, today, our company, we like to think that we're the leader in the U.S. on tracking down this interference, but it's really pretty manual. We go out with a spectrum analyzer and a directional antenna, and we search around for the interference. Because when AT&T calls us, they don't know exactly where it's coming from. They just know that this sector is not working and all the calls are dropping, and management is very upset. That's
so the robots are not coming for your job anytime soon?
Not yet.
Not yet.
Yeah. I had a professor that I asked him why he was working on Bayesian analysis, and he said, because I won't be replaced by a robot. So you have to find a job that a robot can't do.
Yep.
It gets harder and harder.
That's a challenge for all the folks sitting in the back of the room. Old guys like me, it doesn't matter anymore. Yomna, to go back to IMSI catchers, are those apps any good that you can download?
Yep, so there are reportedly quite a few apps that you can use to detect IMSI catchers. The general consensus from the security community and the research community is that most of these apps don't work very well. They're not trustworthy. There's a very high false positive rate. So a lot of these apps...
What does false positive mean?
False positive, it just means like false alarm. Like the app will go off and be like, IMSI catcher nearby, but like actually there like won't actually be anything significant. And that's just because I think like the people who designed these apps didn't know how much like there's like constantly maintenance going on cell networks. Like sometimes like the software on cell towers will reboot And during the rebooting process, the tower will broadcast like weird parameters, and then the app will see that and will just like freak out and be like, warning, warning. But also, speaking a bit more technically, part of why it's hard to do accurate like tower fingerprinting with software running on a phone is simply on like Android and iOS. Like the Android and iOS APIs don't give you like low enough level access to what's referred to as the baseband APIs. So sort of explaining this simply.
What's an API?
Oh, what's an API? So it's sort of like how you interact with like other parts of software and hardware. It stands for Application Programming Interface. So you can't get enough information from like the hardware parts of the phone. So what's called the baseband. And that's sort of where you get information about like the phone's like radio stuff. So it's hard to do that accurately. And a lot of people don't realize that.
So let's jump all the way from the baseband to institutions. I want to circle back to talk a little bit about standards. And you know something about that too, Yomna, but you've actually been the chair of an organization that was very closely involved with standard setting. 3GPP, which is the industry organization for the cellular industry, has been working very hard on a series of standards. And if you want to know where we are on those standards for the topics we're talking about today, go and look at Jeff Reed's slides. What's your experience of standards?
A couple of things. First, just a minor correction. The GSM Association is largely driven by operators, and they come up with requirements. And then the standards bodies convert those requirements into detailed technical specifications that are then broadly agreed and then accepted and implemented, right? So, but generally, the standards setting process is very complex, involves many diverse players, takes a lot of time. There are big, original equipment manufacturers, there's intellectual property holders, there's operators, there's product companies, and it's largely a negotiated settlement. And often it can be a compromise. It's a very, very complex process. The bottom line is that, time is not your friend, right? Because these things take a long time, and many of these things are attempted to be done by consensus as it begins. So it takes a long time, which is one of the problems with how we evolve things, right? There's so many voices. How do you pull in the right ones? The bottom line, though, at a high level, as I see it, is the end result is typically not necessarily the best technical solution for the problem, right? It is one that is implementable, right, and agreed by the parties, right? So that's a bit of the bad news. I think, though, that the good news is that standards continue to evolve, and when they find a problem, they're able to come back and fix it again. But it can be a mind-numbing process. It takes a long time. I mean, years ago, I was deeply involved in the process, and it's painful. It takes a lot of time, and largely, even a big company, for it to get its voice and its way, you really have to create a consortium of other people as well. And there's so many diverse voices now, from the operators to the social media companies who play as incredibly loud and strong voice these days.
One of the things, as I understand it, that happens in these standards bodies is they are faced with a feature request or a problem that they have to solve. You have all these different stakeholders get together, and they, being engineers, they immediately agree, being engineers, they will then all have solutions that they think are perfect. If there is enough time, you can get to consensus. If you don't get to consensus, there are options.
Yes.
So how do these options in standards affect what we can depend on them to do?
That's a great question and a great point, right? These options can be very valuable for those that want to implement them and those that know how to implement them. But one of the challenges with, for example, the 5G standard is there are so many aspects to it that, as Pierre has said, in order to get to a decision, they'll say, listen, this isn't a required portion of the specification. We'll call this an option, and we'll put it over here, right? And there's many, 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 many options. But there's also many, many operators who will buy this version of the software, implement it, and might turn on certain options or not. But then they have to interoperate with their neighbor, and for that matter, every operator around the world to be able to send traffic back and forth, right? And so these options create, or the lack of, with so many options, it's almost impossible to test them all, right? It would just take forever. There's been an attempt to reduce it way down, but it tends to swell back up again. But it leads to interoperability problem, and in our case, it leads to additional vulnerabilities, right? With so many options and the lack of time to thoroughly test them all in great detail, by definition, they lead to some vulnerability opportunities.
Yomna, you have worked with IETF, which is a different standard organization. How would you compare and contrast that with 3GPP?
Yep, so I've done some work with the IETF, which is short for the Internet Engineering Task Force. So they're the organization that put together the standards for things like HTTP, HTTPS, TCP, things like that. So I think the thing that strikes me the most about the difference between the IETF and the 3GPP is, so anyone can, like, literally anyone can join an IETF mailing list and start contributing. They can send emails. They can propose changes to the spec. Generally, of course, it's encouraged first to sit and watch for a while and wait until you really understand what's going on. Otherwise, people won't take you seriously. But it's quite different with the 3GPP. So if you want to be able to contribute, you need to be able to pay tens of thousands or even hundreds of thousands of dollars, depending on the size of your organization. So of course, that cost makes it quite prohibitive. So advocacy organizations can't join, independent security researchers can't join, university labs that can't afford that fee can't join. Yeah, so I think that as a result, the set of groups participating in the 3GPP standardization process is not anywhere near as diverse as it can or could or should be. And recently there were efforts by the IETF where they started a human rights protocols working group. And what this group does is they work with other parts of the standards organization, and they evaluate the standards to be in all these various human rights abusing scenarios, will these protocols hold up to attacks by nation states that we've seen? I think it would be really good if years from now the 3GPP could do something like that.
Right.
Yeah.
So what you're saying is that there is actually an impact on the quality of the standards that are produced if the diversity of participants isn't so great.
Mm-hmm. It's very true. I mean, this is a fact, and it would be helpful. But even then, right, there's this problem of, when I was Chief Technology Officer at Bell South, we had a lot of clout. We had a loud voice. But we could never get anything through unless we could create a consortium of other like-minded operators. And then we would strong-arm our vendors to support it as well across the whole value chain, right? And then it was still a struggle, right? So even when we were absolutely convinced that the solution was vastly technically superior, had no intellectual property wars to wage or gain or lose. There's a number of problems with the standard settings. It's an imperfect process, but there are a lot of people working round the clock to make it happen. It's a thankless role.
Right. Before we turn to Q&A, and just for the students in the back of the room, now is the time to start thinking about what your question is. I want to just turn to Jay. There's so much more. I just wish we had another hour. But I want to jump from 5G standards to, in a way, the other end of the spectrum. You do a lot of work in public safety. You work with organizations like utilities that are using systems that are like pre-90s or 90s era technologies.
They are.
That don't have these kinds of things. What does that mean for the risk profile?
Well, I guess there's a couple things going on there. One is that they're using old technology. So if you think about public safety, and specifically the public safety standard, which is P25, Project 25, that is essentially 2G cellular technology. It's not too different from that. It's different in the sense that it's tailored for public safety, which means it's a one-to-many type of call as opposed to one-to-one type of call. And it also has the ability to be able to talk from subscriber radio to subscriber radio, which cell phones don't do. They have to go through a base station and then come back. But other than that, it's basically 2G. Well, 2G is early 90s. So AT&T just turned off 2G several years ago. They don't, the GSM system, they don't even offer it anymore. You have to go to some remote parts of the world to use GSM phones. So that limits what you can do because it's old technology. The biggest limitation is data rate, bandwidth. These are narrowband channels. You can't do what you can do with your cell phone. But there's other problems, and the other problems really are a consequence of economies of scale. With cell phones, you have these enormous economies of scale, so you can put what is very expensive technology to develop in a cell phone, and it'll be cheap because you're going to sell millions and millions of them. Well, the vendors of public safety radios, there's only a handful of them, Motorola, Harris, Tate, Ericsson, and Kenwood. Those are basically the main ones. Those vendors don't have that advantage of economies of scale. So they can't afford these large development costs because they'll never be able to get their money back. And so there's features in those radios that you would like to have that you can't have. Now, despite all that, believe it or not, P25 has a good encryption scheme. And it was approved by the federal government. And federal government users use P25 as well as police departments and fire departments. So they've got the encryption down pretty well, but one of the problems you have is a police department buys a new radio system maybe every 10 or 15 years. Hard to believe, right? Because we replace our phones every 2 years, or maybe even sooner. But that's what they do because the capital costs are so high. That's all they can afford to do. And when they do that, they have to hire outside experts, and that's where we come in to help them. Because you can't have staff on your payroll that you only need every 15 years. It's just not going to work. So you hire experts to come in and help you, and the experts then have to tell you all the things that you're doing wrong. For example, we had one police department in Colorado that wanted to buy a new P25 radio system. This was before FirstNet was available, so it was a few years ago. And the encryption cost extra, and specifically the encryption for the GPS coordinates. And so we said, well, I think we really want the encryption. And the police chief said, well, it's too much money. I don't have any more money in my budget. And I said, okay, chief, let's say you've got a SWAT team surrounding this criminal domicile, and you're trying to be stealthy and sneak up on them, but the criminals are very sophisticated, and they got scanners in there, and they noticed that all the cops are around their house. You don't want that to happen, obviously. And so he said, okay, we'll buy the encryption.
Wonderful.
But you had to go through it. And just to put it into perspective in terms of numbers, because we talk about the global economies of scale, but very, very quickly, in the U.S. there's, 320 million people, and there's more cell phones than that. But, depending on how you count it, there's close to maybe 3 to 4 million public safety. So their use of proprietary networks, and solutions, they paid a huge price for it because they could never get out of it. And thus, one of the huge justifications to move to the latest and greatest technology and get there, right? So they can actually take advantage and solve some of these problems.
I think almost everybody in public safety agrees that FirstNet is where they want to be. Mm-hmm. It's going to take them a few years to get there, but that's where they want to be because they want that modern technology. They have all kinds of apps that they can use on broadband devices, but they can't use today because they don't have broadband.
Good. So let's turn to questions. We have a custom at Silicon Flatirons that the first questions go to students. So any students, just raise your hands to see how many students we have. We have 2 here. So could we just have the mic in this row? And actually, let's just get both your questions. And actually, there's another question behind you. Let's just get all 3 of those questions out and then let the panelists answer them. Since we're trying to catch up on time, please go ahead. Identify yourself.
My name is Kennedy Smith. I'm a student here at CU. I'm in the Tech Law Clinic. And my question, I want to go back to the 3GPP just for a second. We were talking about kind of balancing different interests, and I was wondering what the opinions on the panel were about whether the 3GPP has been sufficiently prioritizing these known vulnerabilities over things like going to market and the other interests of the organization.
Great. Let's just get 2 more questions and then we'll turn to the panel. So,
You're going to consolidate your
You consolidate. Okay, and so then the lady.
I'll ask one more. So I'm Andrew Lady. I'm also in the tech clinic. Also interested to hear about kind of, it was discussed that the 3GPP standard setting process was kind of an iterative process, and kind of understanding though that it's quite insular. I just was interested to hear about kind of the timeline for when a new vulnerability is discovered, how long it takes for the 3GPP to kind of address that vulnerability in a meaningful way.
Great, thank you. And another question, lady in the white. You're good? Okay, fine. So a couple of questions.
No, let me respond to the first question, right? Do you believe 3GPP is adequately focusing on these things? I don't, right? And it's one of the reasons I'm here, because, I believe that, with 5G there's been significant focus on super fast, high speed, ultra low latency. And there's great reasons for that, right? Who doesn't want super fast? Who doesn't want to be able to experience this low latency? How are we going to control autonomous vehicles going 60 miles an hour in opposite directions, if we don't have absolute, you can't afford what's called jitter or delay. And so I don't believe the priority's been there, but they have been, by definition, it's been at the expense of resiliency. But it's not that the sky is falling, right? There's been a ton of work that's gone into it, right? And I'm here speaking up now because I do think that there's more work to get done. And the priorities need to shift now, right? The products are rolling out into the marketplace. We have to be very prepared to deal with the problems we already know about and the ones that are about to really hit us in the face, right?
Yep, so I'd say I agree with Scott. Just as an anecdote, so in the reading that was put out before for this event, one of the papers was on the how easy it is for someone to send out a fraudulent presidential alert. So that paper I think comes from the University of Colorado Boulder, but there was a similar paper that came out of a group called KAIST in Seoul, South Korea, a very big mobile security research group, where they described an even broader attack, where the fake presidential SMS alerts is sort of a subtype of that attack. And they took it to the 3GPP, and they were like, look at this awful attack. It would be trivial to pull off in a sports stadium and freak everyone out with this fake emergency alert. And as of a few days ago, the 3GPP's response was basically yeah, we don't really think this is applicable to real world scenarios. When it's that's clearly not true, especially given if you think about what happened in Hawaii. I think it was last year in early 2018 when there was that fake that mass fake emergency alert about the incoming missile. That really freaked people out.
Very good. Any other questions? Let's see if we have time for let's say 3 more questions. Let's just bundle them together. That lady and then those 2 questions over there, please. And then we'll have to wrap up.
Hi, my name's Shannon. I'm a first-year TCP student in the engineering school. Does FirstNet, is the purpose behind that to solve the problem of Verizon throttling fire departments in the midst of responding to terrible, terrible disasters?
Yep. Come back to that one. Yep. Thank you. Great question. And then 2 more questions back there. The gentleman there in the teal shirt.
Hi, I'm Grayson. I'm a 10th grader in Longmont, and I was wondering, in kind of the ideal world, how would a standards organization kind of operate and develop these standards that are universally used?
Great, thank you.
Grayson, why aren't you in school?
Very simple.
You'll learn more here.
Yeah.
Hi, I'm Lex. I'm a junior over at Silver Creek in Longmont. And I was wondering, is there an actual way they can develop an app or a program to detect these MCP catchers and stingrays?
Very good. So, go ahead.
Yeah,
what problem was FirstNet solving?
So the problem with Verizon deciding to throttle, the police department during the disaster is not something that FirstNet is, in my opinion, it's not something FirstNet is actually responsible for from any official perspective, but you can believe that FirstNet was actively involved in responding and putting leverage on so that this didn't happen again. So it's not really FirstNet that's responsible for this. There's other agencies, but the public outcry, I think, was what really got them to change it pretty quickly.
Yep. How wouldn't this is probably something you could write a dissertation on. By the way, the reason why we have this rule of students go first is that they always ask the best questions. So, so how should a standards organization work in the ideal world? That's a dissertation right there.
Yeah.
Any quick thoughts on ways in which we might be able to improve the standards organizations to do a better job at this problem?
So one thing that I think could make things better is if security researchers, like public interest security researchers, were included in the standards process like much earlier on. A common problem, especially in software engineering, is like developers will like write all their code and then like they'll spend like 8 months on it, and then like the last 2 weeks they'll be like, okay, security people come in and look at it, and by then it will be too late to fix like the structural problems. So that's one thing, and also like a more diverse like stakeholders involved in the standardization process, which is definitely something a 3GPP could do.
Right, and to the question on, are there apps? There are, and I think you actually discussed them in your paper, so go to the EFF website and look for the paper on IMSI catchers that Yomna wrote.
It's called Gotta Catch 'Em All. It's a Pokemon reference, so it's easy to remember.
Okay. Very good. Actually, I have had to shut down my friend and colleague here. He had another comment, but we are way out of time. I would like to thank this panel. We are going to go into a break. Could I ask you to try and be back here by 10:02 if you can? Just a word to the wise, the restrooms are at the end of the long corridor. If there is a line, go up one floor. There's another matching restroom, one floor up, and then another floor up. See you in 10. Thank you. Sorry.